All right, everyone, get ready, because today we are diving into a theory of the universe so wild it makes the Big Bang look like a dropped ice cream cone. Are you ready for this? We are talking about a universe that didn't start with a bang, but with a whisper. A whisper so quiet it was basically the universe realizing it existed.
Precisely. It's the ultimate if a tree falls in the forest scenario. This model proposes that the universe began not with an explosion, but with an observation, the simplest act of noticing a difference.
Okay, hold up. Noticing a difference. What does that even mean when we're talking about the very beginning of everything? Like, what's doing the noticing?
That is a great question, and it leads us to one of the most fascinating parts of this model. The observer now, forget about picturing a person with a telescope or even some kind of cosmic consciousness. It's much more fundamental than that.
Even more mind-blowing than a cosmic consciousness. Color me intrigued.
Think of it this way. The observer in this model is like the most basic unit of detection imaginable. It doesn't need eyes or a brain or even awareness as we understand it. It simply exists to register a difference, a change in energy levels, however minute that change might be.
So instead of a big explosion, we have a tiny difference that gets noticed. It's the ultimate underdog story.
Exactly, and it's that act of noticing that registration of a difference that brings the observer, and by extension, something into being.
You know, I'm starting to get why we call this a deep dive. So we've got this observer, this super sensitive difference detector. What is it observing? Where does this first difference even come from?
Picture, if you will, an expanse so vast, so utterly uniform, that we can only call it near nothingness. This isn't to say that nothing exists, but rather that everything is almost, but crucially, not quite the same.
So like a cosmic game of spot the difference. And these observers are popping up wherever they find even the tiniest discrepancy.
Precisely. And the moment an observer detects a difference, it's like a tiny pathway lights up a channel for energy to flow.
So we have these little energy pathways popping up all over the place, connecting these observers. Are you saying this is the beginning of like a cosmic energy web?
Exactly. And like any good web, this one starts to grow this network fueled by pure randomness, and the constant detection of new differences expands outward, forming a flat circular surface. And you know what's even more mind-bending?
What could be more mind-bending than a universe-sized spider web made of pure energy?
The web itself is the space. It's not expanding into an already existing space, it's creating space as it goes.
Wait, so there's no pre-existing void for this web to stretch across the web itself? Is weaving the fabric of space? Now, that's a concept I can get behind, but last time I checked, telescopes show us a universe that's decidedly more spherical than web-like. How do we get from a flat energy web to the universe as we know it?
That's where things get even wilder. Enter the universal bias. Imagine that within this vast expanse of near nothingness, there exists the slightest preference for one direction.
So something like a cosmic breeze, a subtle nudge influencing the energy web. What could cause something like that?
It could be anything, a quantum fluctuation, a tiny energy gradient, but the point is, in a system as vast as even the tiniest bias is inevitable, and this bias has a fascinating effect on our expanding web.
I'm sensing this is where the flat web gets crumpled up into a ball, right?
You got it. The bias causes the expanding flat surface to curve ever so slightly, like a balloon inflating with a tiny weight on one side. It's not a sudden warp, but a gradual curvature over unimaginable distances.
So picture this, listeners. A flat plane slowly, majestically curving in on itself until, bam, it closes in on itself, completely forming a sphere. But this is no ordinary sphere. This is a universe-sized sphere born from a flat energy web, all thanks to a tiny, inevitable bias in the fabric of existence.
A universe-sized vibrating sphere, to be precise, and that's where things get really interesting.
That's right. It's a sphere, but it's not just sitting there like a cosmic marble. It's more like a giant, interconnected bell that's been struck reverberating with energy.
I'm trying to picture this giant vibrating sphere. What's causing all that shaking and shimmying? Remember those energy pathways as connections between the observers. They're not static. They're constantly flowing, adjusting, seeking balance across the entire surface of the sphere.
So it's like the entire sphere is engaged in a kind of cosmic dance with energy flowing back and forth.
Exactly. It's a dynamic system, always striving for equilibrium. But here's where the shape of that sphere really comes into play. You see, the curvature of the sphere combined with all this vibrating energy sets off a chain reaction.
Okay, I'm strapped in and ready for this chain reaction. Hit me with it.
As the sphere vibrates, the curvature causes the energy pathways to draw closer together over time. Imagine those lines we talked about on a deflating balloon. They get shorter and shorter as the surface shrinks.
So even though nothing is squeezing the sphere from the outside, the energy web is gradually tightening its own belt, so to speak.
You've got it. And as those energy nodes get closer and closer together, especially near the center of the sphere, the whole system starts to collapse inward.
Whoa, hold on. Does this mean our entire universe is shrinking? Should I be worried about fitting into my genes next year?
That's a great question, and it highlights just how mind-bending this model is while the energy web is contracting. It's not shrinking in the way we typically imagine. It's more about the energy density increasing at the core of the sphere.
Okay, so it's less about the universe getting smaller and more about things getting denser. But how does a super dense ball of energy turn into stars and planets and all the stuff we see around us?
That, my friend, is the million-dollar question. You see, this core, this concentrated point of energy can only become so dense before it reaches a critical point.
It's like trying to cram an entire universe's worth of stuff into a cosmic suitcase.
Exactly.
Something's got to give.
Exactly. It's like a cosmic pressure cooker, and eventually all that pent-up energy needs an outlet. And that, believe it or not, is where matter as we know it comes into play.
Okay, you've officially piqued my curiosity. How does energy transform into matter?
Indeed.
Okay, so we're picturing this cosmic pressure cooker ready to blow, but instead of exploding outwards, it's more like it's going to release its energy in a very specific way.
Yeah, you've got it's like imagine a pressure cooker with a million tiny valves, and each valve releases just a little bit of steam, but in a very controlled way.
Okay, I think I'm following. So this energy from the core is going to start flowing out into the near nothingness through these metaphorical valves.
Right, and as it does, it encounters more of that near nothingness. Remember, that's where those observers come in, they detect the difference, and bam, energy starts flowing, creating new connections, new pathways.
So it's like the universe is rewiring itself as it goes constantly adapting and changing.
Exactly, and those new connections, they aren't just random. They're shaped by the underlying structure of this near nothingness, the way energy interacts, the geometry of the connections. All of that influences what forms.
It's like this primordial energy has a set of blueprints. It has to follow a cosmic building code.
I like that a cosmic and just like in the physical world, different building codes result in different types of structures, right? Well, in this case, those different structures, those patterns of energy are what give rise to the particles and forces that make up our universe.
So you're saying that the very essence of matter, the stuff that makes up stars and planets and even us, comes from these specific ways that energy is allowed to interact.
Precisely. It's not just about the energy itself. It's about how that energy is organized, how it's structured, and that structure ultimately determines what kind of universe we end up with.
You know, this whole idea of observers popping up wherever there's a difference, it makes me wonder, could there be other spheres, other universes out there, all forming from the same near nothingness?
Now, that is a truly mind-blowing question. And you know what the really wild part is? There's nothing in this model that says it's impossible.
So we could be just one bubble universe among countless others, all bubbling up from the same primordial soup.
Exactly. And think about the implications. Each of those universes could have its own unique set of building codes, its own way that energy interacts. And that means each one could be wildly different from our own.
Different laws of physics,
Yeah.
different types of matter, maybe even different dimensions. It's enough to make your head spin.
And here's another thought. What if those universes aren't completely isolated? What if they interact in ways we can't even imagine?
Cosmic collisions, merging universes, maybe even universes influencing each other in subtle ways.
Yeah.
Okay, now you're just messing with me.
Well, we have to leave something to the imagination, right? But
Yeah.
that's the beauty of this model. It pushes the boundaries of what we thought was possible and opens up a whole new realm of cosmic possibilities.
And on that note, we're going to leave you, dear listeners, with a final thought to ponder, what if our universe, this incredible, vast and complex cosmos we call home, is just one tiny bubble in an infinite sea of possibilities? Until next time, keep looking up, keep asking questions, and never stop exploring the wonders of the universe.